Here's an example. A standard 100-watt light bulb requires 120 volts to produce the designed light output, measured in lumens. If the voltage drops to 108 volts, minus 10%, the light bulb still works, but puts out less lumens and is dimmer. If the voltage is removed, as during a power outage, the light goes out. Either a low voltage or complete power outage does not damage the light bulb. If, however, the voltage rises to 130 volts, plus 10%, the light bulb will produce more lumens than it was intended to, causing overheating and stress to the filament wire. The bulb will fail much sooner than its expected design life. Therefore, we could conclude that as far as a standard light bulb is concerned, a power quality issue that shortens the bulb's life is high voltage. We could conclude that low voltage or power outage would cause the lumen output to vary, which affects the intended use of the bulb. Again, the term power quality in different contexts means different things. For different devices, this minus 10% situation could be considered a power quality issue, but it's not a power quality issue for this light bulb. So here's more, another example of a power quality issue. A CRT, or a monitor for a personal computer, this one, like I'm sure you're all looking at right now, uses 120 volt AC power supply to convert the incoming voltage to specific DC voltages required to run the monitor. These voltages include 5 volts DC for logic circuits and high DC voltage to operate the cathode ray tube, CRT. Yeah, cathode ray tube. If the incoming voltage drops to 108 volts, minus 10%, the power supply is designed to draw more current or amps to maintain the proper internal voltages needed to operate the monitor. As a result of a higher current draw, the power supply runs hotter and internal components are stressed more. Although the operator of the monitor does not notice a problem, the long-term effect of running on low voltage is reduced reliability and an increased failure of the monitor. If the power drops below the operating range of the power supply, the monitor will shut down. If the voltage goes above 132 volts, plus 10%, the power supply will not be able to regulate the internal voltages, and internal components will be damaged from high voltage. Therefore, we conclude that the power quality requirements for the PC monitor are much higher than for a light bulb. Both high and low voltage can cause premature failures, where it was really just high voltage for the light bulb. The economic issues are much greater for the PC monitor in both replacement cost and utilization purposes. Again, driving home the point that the term power quality is a catch-all term that doesn't necessarily mean just one set of things in all contexts.